All right, guys. So we are now moving on to exercise 5B, question number 1. So they say an accountant monitors the number of items produced per month by a company together with the total production cost. The table shows these data. The number of items are in thousands. Now bear in mind about the unit, and the production cost is also in thousands of pounds. Okay. So number of items 21. In other words, it's actually 21,000 items. And the production cost of the 21,000 item is 40,000 pounds. Can you guys see 40,000 pounds? Okay, so these are all in thousands. So bear that in mind when you give your answers. Okay, so these are all the points. For 39, the production cost is 58. Okay, in thousands. So guys, they've given you a lot of points like this. They're asking you draw a scatter diagram to represent this data. So you take a graph paper and you can plot the points, right? It's a really small thing. So I'm not going to take time over that. All you need to do is just to give the points and, get the XY values and just plot the points. Okay. And then in part B, they say the equation of the regression line. So I think you now have an idea of the meaning of regression line, right? Regression line means the line of best fit. Okay. So the line of best fit is the line that goes best through all these points, that minimizes the error, right? Because the real point and the actual line, there's a slight error where it goes, right? Because the real point is over here, but the line is a little bit below. So there's another point, the line is a little bit above. So regression line tries to, keep that distance at a minimum. Do you recall? I think I've explained that previously, right? Okay, so anyway, they have given you the regression line. Okay, so still we did not go for the part involving the calculation of the regression line, but they've given you this. So all you have to do here is they're asking you to draw the regression line. So how do you draw the regression line? So take a few coordinates on the line. So maybe n equal 10, n equal 20, 30, 40. You can try a few points and actually draw the line. Okay, so so these points mark it in another color. It's easier if you mark it in another color or another. Maybe if you mark the points here, mark crosses for the coordinates on the line, and then that you should be able to connect it directly from a straight line because you are generating points on a straight line. Okay, I hope you guys can understand what you need to do. So you just have to input values for n. So try n equal 20 and get the p output. Try n equals 40, get the p output. Try n equals 60, n equal 80, get the output. Actually, even two outputs are enough to draw a straight line, right? So all those points will come perfectly on a straight line. Okay, and then you put those values and draw the and you draw the straight line. So you get this. Okay, so those are really simple things. I'm not going to go into that. Okay, so we'll actually move on to the important part. So this is the important thing. So previously I taught you how to interpret the meaning of these numbers. Now you can see they are saying interpret the meaning of the numbers 21.0 and 0.98. So I did give you an idea how to interpret the intercept and the gradient, right, guys? So I gave you a kind of an idea how to interpret the gradient and how to interpret the intercept. So 21, as you guys can see, 21.0, when you consider the straight line, 21.0 is the intercept, right? Equal 21.0 plus 0.988. So you guys can see 21.0 is the intercept, 0.98 is the gradient. So I've given you the idea how to interpret the intercept and the gradient separately, right, guys? Okay, so how do we do that? All right, guys. So, how do we interpret the intercept? So, intercept. I've given that to you, right? So, I've told you that intercept is, basically the x value is 0. You draw this line longer, and intercept is the place where you cut y, and when you cut y, x value is 0, right? So, the number of y units produced when x is 0. So, basically, here your x is the number of items, right? So, the number of items is 0. You are not producing any items. Okay, so there are no items produced, but the y value, the y units are production cost. So you can see the production cost is what? Now the production cost when x is 0, okay? So your production cost is going to be 21. And by the way, don't say 21, you know your y, the production costs are not just in these units, but they are in thousands, right? So guys, you have to give that in the proper unit. Say it in the proper units. It's not 21, but 21,000 pounds, right, guys? So you can say, what can you say here? The C value. Okay, so the C value here, 21. You can say when there are no items produced. When there are no items produced, the production cost is approximately, you can say, okay, so or the production cost will be or is approximately equal to, so guys, the Y units are in 21 now, over here 21, but remember it's in thousand, so it's going to be equal to 21,000 pounds. Can you guys see? So this is the interpretation of the 21, the intercept. All right, guys. Actually, I changed here. I gave you the equation of the regression line as y equal a plus bx, right? Okay. So here p is the y. Okay. So a is 21. The b gradient is 0.98. So n is in place of x. All right. Now, how do you interpret the gradient? So for gradient, I have given you the rule, and that is so when you change 1 unit of x, okay, the gradient represents the number of change in the units of y. So I've given this to you very clearly. Okay, so gradient represents when x changes by 1 unit, y changes by the b number of units. B is the gradient amount. Okay, so you can say when x changes by 1 unit. Now, who is x here? X is the number of items, right? The number of items when you, let's say, increase. Now, change in the sense you can say always go for x when x increases by 1 unit. You can say like that. So when x increases by 1 unit, guys, now the thing is this. If you increase x by 1 unit, the problem here is we are measuring our x in thousands, right? We are measuring our x in thousands. So if you increase it by 1 unit, guys, you need to understand a single unit in the number of items is representing what? A single unit is, I mean, every single unit is measured in thousands. Can you guys see? Because everything here is given in thousands. So when you change x by 1 unit, when you increase by 1 unit, means when you increase by 1,000. That's really important because here a unit is specified as 1,000. Okay. So you can say when the number of items, next one. Okay, this is the interpretation of the intercept, this is the gradient. So when the number of items, produced increases, so go with increase. Okay, so you can say increase or decrease. So we'll go with always for x, go with increase. When the number of items produced increases by 1, normally we say 1, but over here 1 unit is 1,000. Okay, so that's why I'm saying 1,000, guys. That's really important. Normally we change by x by 1 unit. But over here, 1 unit is 1,000. So if they said here instead of 1,000 or 10,000, I would say 10,000 here. If they say instead of 1,000, 100 here, I would say 100. Okay, it all depends on what they tell here. Okay, so 1 unit, the way they specify here. So when number of items produced increases by 1,000, what happens? Y increase or decreases according to B. So who is Y? The production cost. Okay, so make sure you substitute the correct word. So Y means production cost. Production cost is increasing or decreasing. Production cost, you can see you have a positive gradient, right, guys? The positive gradient means you can see when x is increasing, y is increasing. That's the meaning of a positive gradient. Okay, so that's why. So I'm checking the sign. A positive gradient means when x increases, y increases. A negative gradient would mean when x increases, y decreases. So over here, when x is increasing, I understand my y should also increase. Okay, so production cost increases. That's really important because you have to choose the word here. Okay, production cost increases. This word is something that you have to choose. The x1 you didn't have to choose. For x, always say when x increases. For the x item, you always say when x increases by 1 unit. Y increases or decreases. In the case of y, you have to choose depending on the gradient. So production cost or y is increasing, or production cost increases by the gradient. What's the gradient here? 0.98, right, guys? But the thing is, I told you the 0.98, the gradient, the production cost is in 1,000. So guys, measure this, multiply this by 1,000. 0.98 into 1,000 is 980, and it should be pound. When the number of items produced increases by 1,000, production cost increases by 980. So this is the most important thing. Okay. Moving on to the next one. Okay, so they say the company expects to produce 74,000 items in June and 95,000 items in July. Okay, now when they say the company expects to produce 74,000 items, according to this table, guys, 74,000 means the table value is 74. Can you understand? And 95,000 items in July means the table value according to this is 95. Understood? Because the table values are in thousand. They say comment on the suitability of this regression line equation to predict the production cost in each of these months. Okay, so for this also, I gave you a rule. Do you recall? So I gave you a rule. I told you something about extrapolation and interpolation. So if you use the regression line to predict, now you know you can use your regression line to predict the y outcome, for any x, right? So you can input any x value. Now you have a certain amount of x values here, but you will want to probably see the production cost for different x values, right? Even ones that are not on here. So you can use the regression line to predict the cost, right? So when x is 30, when the number of items produced is 30, you can easily use the line to get the production cost, the y value. So they are saying now they are going to do that. They are saying they are producing 74,000 items. Guys, 74,000 items means according to the table input. Okay, so in part B, the table values for 74,000 is n is 74. And the other guy is 95,000. The table input value is n is 95. So my question is it okay? Now, if we use, you have the regression equation here. All you have to do is use n as 74. Can you see? Go to the equation, replace n with 74, and immediately you get the p-value, the production cost, right? Over here, the next one, you go to the table, input n as 95. You input n as 95, multiply with 0.9, add the 21, and immediately you get the production cost. Right, guys? So that's the production cost. So you get that. Now the thing is, they are not asking you to get the production cost. They are asking you comment on the suitability of this regression line to predict the production cost in each of these months. So using n as 74, the answer I'm getting for the production cost, is it reliable? I'm going to use n as 95 and I'm going to get the answer for P. Is it reliable? That's the question. So I gave you the rule. Do you recall? So I have told you that you can only use the regression line to what? To predict values of x that are in the range. So you should not use this to predict anyone who is actually outside the range, because outside the range, guys, you need to understand this line is actually adjusting itself to every single point. Okay, so guys, I'll show you the calculation in the next exercise. But you need to understand this line is taking every single point into consideration. Now imagine we took another point, another extra point over here, and that extra point came like this. Okay, say I take another point and it came like this. Guys, this equation, the gradient would definitely change to adjust to this, because it's trying to minimize the errors from with all the points. This line would change, the gradient would change if another point came like this. So every single point is taken into account. Do you understand? So because of that, that is why they are saying you that if you use anyone outside of this, now, you have your data set within these boundaries, right? So if you go to predict anyone outside the boundaries, we don't know whether the line gradient will change. So that's one of the main reasons. Now, if you check n equals 74, guys, is it in the range? So what do you think about n equals 74? If you look at the graph, I think I can see n equals 74 is definitely in the range, right? Can you see? 74 is definitely, the graph is going through n equals 74. Can you see? So clearly it is in the range. So you can say for n equals 74, n equals 74 is in the range. Is in the range. So the answer, the production cost you get here, is it an answer that we can depend? Yes, you can depend on this answer. You can be kind of sure that when you use n as 74, the production cost you get is correct. It should be approximately correct. Can you guys understand? Okay, so let's write that down. So guys, over here, so when n equals 74, you can say the 74,000 is within the range. Even if you can say 74,000 if you want. 74,000 is within the range of the data. Therefore, the answer given by the regression line will be reliable. And they are not asking you to actually get the answer. If they wanted you to find the answer, just replace n with 74, multiply by 0.98, add 21, and get the p-value. And final p-value, the production cost, you should multiply that answer by 1,000. So they're not asking you to do that, so I'm not going to do that. All right, guys, and the next one. Okay, what about n equal 95? So what is 95 inside the data point or outside? So how do you check that? The one of the easiest ways is, I think you can see it from the graph. I think the largest x value we have here is 81, right, guys? The largest x value we have here is 81. I think none of the x values are exceeding 81. Can you see? So our graph here ends at 81. So actually, by the time we go to 90, we have no information. After 81, we don't know what's going to happen, whether the points will change drastically. We have no idea. So in that case, when you're, so this is actually what we call as extrapolation. So if you use n as 90, since your graph, since your data doesn't extend to cover those areas, you should you should not use your regression line to give predictions for such data point. Okay, so you will not use it. We don't know whether things will change. So you can clearly say 95,000, right? So 95,000 is out of the range, or you call that extrapolation. So 95,000 is outside the range of data. That's what we call as extrapolation. When you are inside the range, you call interpolation, okay? So 95,000 is outside the range of data. Therefore, the answer or the prediction, because we are predicting the y value, right? The prediction therefore the prediction is less reliable. The prediction means the y value. The y value is not going to be reliable. You can't trust on that y value. We don't know what's going to happen. So you should not use your regression line to estimate anyone who is outside the range. All right, guys, it is clear. All right, guys. Okay. So we're moving on to question number 5 in the same exercise. So again, they are telling you the table below shows the data on the number of visitors to Ireland in a month, V in thousands, and the amount of money they collectively spend, M, in millions. Can you guys see? So now the scales are different. So very clearly check on this. Okay, so yeah, X is in thousands. Okay, so your X is in thousands and your Y is in million. All right, guys. Okay, so the amount of money spent is in millions of euros. So they say here that, okay, the equation of the regression line of M on V equal minus 467 plus 0.740 V to 3 SF. Okay. So this is the equation of the regression. They've given it to you. They're asking you given interpretation of the gradient of the regression line. All right. I think guys, they're not asking us to draw this, but anyway, we've drawn it, right? So we've actually taken the points and, we've taken, so actually I explained to you guys how to draw it, right? You draw the scatter plot and then you take points on the straight line and then you draw the straight line and the regression line should give you the basically called the line of best fit. Okay, so don't worry about this. They are giving it to you in this exercise, but we will very soon learn actually how to calculate this regression line, how to get the line of best fit, the in-depth working. We will go through that part very soon. Okay, so over here they are not actually, so they are not asking you to draw, but anyway we've done it. Okay, so they are saying here give an interpretation of the gradient of the regression line. So guys, I just wanted to give the interpretation of the gradient. So how do you interpret the gradient? I told you when x increases by 1 unit, gradient, how do you interpret when x increases by 1 unit? Y increases or decreases, that depends upon the gradient. That y will increase or decrease depending on the b value, the gradient. Okay. So what's our x here? X here is the number of visitors, right? X here is the number of visitors. So when the number of visitors increase by what? What's 1 unit here? 1 unit here is in 1,000. So you should say when X increase or when the number of visitors, right? So when the number of visitors increase by 1,000, the amount of money spent, right? Y is the amount of money spent. So that will but write down when the number of visitors, when X increases by 1 unit. So when X is the number of visitors, when number of visitors increase. By 1 unit means by 1000. The amount of money spent is going to what? Is going to increase or decrease. I think you can see we have a positive gradient. 0.740 is the M value, the gradient here, the B. So that in the amount of money spent, because it's a positive gradient, right? Because it's a positive gradient, you will write increase. Okay, that's very important. If this was a negative gradient, I would write decrease. Okay, the amount of money spent increases by how much? By 0.740. What? 0.740. Y is in millions of euros. So 0.740 million euros. Can you guys see what's going on here? Right, guys? So be very cautious here. You have to be really cautious about the unit. All right, guys. So I think this equation here, this should be M equal. Okay, this should be not V equal. This is M equal. Minus 467 plus 0.740 V. All right, guys. So actually, I've done a little bit of work here. So you can see if every 1,000 visitors are spending this much, the amount of money spent is increasing by this amount. So 0.740 million is actually, and this is actually optional. Okay, it's not absolutely compulsory. If you can write this down, that's more than enough. So, say 0.740 million is a 10 to the power 6. So I multiply this by, 10 to the power 6, I get 740,000 euros. That's for 1,000 visitors. And you can actually get the amount that one person spends as well. Because, they could ask you a question like, how much does, one person spend? So you could, use this information to actually go for one person. Okay. Okay, let's move on to the next part. This is actually optional. Okay. Okay, so over here they say use the regression line to estimate the amount of money spent when the number of visitors to Ireland in a month is 2,200,000. So guys, the number of visitors to Ireland in a month. Now, this data is given, if you read this carefully, this number of visitors for each month is measured, right guys? Every single month is a single measuring point. Number of visitors in the first month, second month, third month, likewise they've done for 8 months, okay? So they are asking you to estimate, use the regression line to estimate. So this is our regression line that's given to you to estimate the amount of money spent when the number of visitors, the amount of visitors is 2,200,000. Now, guys, the amount of the number of visitors is scaled by what? Is it scaled by using 1,000 or a million? The number of visitors is scaled in thousand. Okay, so be very cautious. So which means your input for the regression line in part B, okay, 2,200,000 should be scaled by 1,000 when you are using it in the regression line. So when you're scaling by 1,000, your V value, right? The number of visitors is V, right? Yeah. Number of visitors is V. V should be, you divide by 1,000, 2,200, right, guys? Because it's supposed to be in 1,000. Okay, it's supposed to be in 1,000. So you remove 3 zeros. So you just divide by 1,000 and that gives you the input. So now use that input because they're asking you to actually find the number of visitors. Use the regression line. That's asking you to use this line to estimate the amount of money, You have to get the M value, the Y value in other words. So use the regression line. So we have here our regression line is M equal minus 467 plus 0.740 V. Okay, guys, that's our regression line. Let's use the input. Minus 467 plus 0.740 times V. V is 2,200. All right, guys. So let's get the answer. What's the M value? So guys, for this, we get the answer 1161, right? That's the M value. But remember, when you use this equation, the M value comes in millions of euros. So make sure you give your answer with the units. This is euros and what? 1161 million euros. So that's really important. Make sure you write the million, or you can write times 10 to the power 6. A million is a 10 to the power 6. Okay, so you can either write million or you can write times 10 to the power 6 and just leave it. Okay, guys, so that's the amount of money, right? Use the regression line to estimate the amount of money spent. Okay, so we found that. Okay, then in part C, they say comment on the reliability of your estimate. In part B, give a reason for your answer. Okay, so once again, we've explained this now in the previous question as well. How do you check if your answer is reliable? How do you know your Y value? The answer I got now, that 1161 million euros, is that an answer that I can rely on? How do we know that? Always, I've told you, you should only use your regression line to input the V values. The inputs that you're using here for V should be within the data range, the V values. Now you have a smallest V value and a highest V value in your data set, right? So whatever the V value you input here should be within those boundaries. It should not jump out. So if you check your V value here, what's the smallest V value we get here? 2290, right guys? 2290 is the smallest V value we have. Right, and then what's the largest V value we have? I think it's 2540, right guys? The biggest 2540, right? That's the biggest. Okay. Yeah, so then the smallest is this, the green one, the smallest P value, the largest is 2540. You can see it on the graph. The smallest is over here and the largest. So then anything in between these two values is perfectly fine. You can use any number in between those two, minimum and maximum, to actually substitute this into your regression line and get a prediction for M. That's perfectly fine. Okay, that's perfectly fine. But they are asking you here now, is the answer. Now we use, what's the value we use in part B? We use V at 2200. So is it in the range? 2200, is it in the range, guys? If you look at the lowest value we have is 2290, right, guys? And the biggest is 2540. Is the value we use V equal 2200. So is it in the range? So guys, clearly we can understand 2200 is what? Is lower than the smallest value we've considered in our data range, right? Our data set starts from 2290. So we are using 2200 here on this regression line. So clearly 2200 is below the value, below 2290. So I told you, you are fine as long as you use any value in between these two, guys. That's perfectly fine. Okay, but not outside of that. So you can say for part C, so you can say for part C, 2000 to 2,200,000 is outside the range of data. Outside the range of data, or in other words, it's an extrapolation. Therefore, prediction, the prediction means the M value you get. Okay, the M value we get is our prediction. Therefore, prediction is unreliable. All right, guys, is this clear? So this is really important. Okay, so this is all you need to know about. They give you the regression line, and we've done the part you do after you get the regression line. So actually now in the next part of the lesson we are going to learn how to actually calculate this regression line. Okay, so I hope these parts are all clear to you.